Good morning, everyone. Today we will try to calculate two different questions to determine the resistance value at the first question. Like the author write it here, find the voltage R1, R2, R3, and R4. And he wanted from us to draw circuit diagrams for every new phase and find the current I3 and I4. The main idea when we facing circuit like that, complicated circuit with many different amount of resistance, like here, R1, R2, 3, 4. We have 4 resistance at the same circuit, and we can say something like 2 loops. At first, we can say V1, the author write it, this value equal 15 volt. That means the different potential between VA minus VB. Let me say B will be the reference point. Let's go to calculate all of these results. At first, I will draw the circuit by using another way. I will use this way. R1 will be at the same, R4 at the same. But I will change the positions to all of these R2 and R3. R3 will be down, R2 will be up. All of these two resistance will be here with something like that. Let's go to the circuit. Yes, like here, R2, I3. R2 was here, R3 was here, between B and C. By that, at first, what does mean? R2 and R3 are parallel resistance. Let's calculate RT1 by saying R1 is series with Rn1. Rn1 is the value between the R2, R3, the value of these two parallel resistance. Let's calculate RT1, R1 plus R2 parallel with R3. What does mean? That's mean R2 dot R3 divided on R3 plus R2 plus R1. By this way, we calculate the R in U number 2. We can say that, or we can say RT, R total 1, RT total 2, it's up to you. Now let's calculate the total resistance to R1, R2, and R3. That's mean Rn1 or RT1, like I said before. 5 plus 8.4 divided on 8 plus 4. The result will be our total one equals 7.66 ohm. What does mean? That's mean here just we have another resistance. This resistance was R4 equals 6 ohm. Now here RT1 and R4 are parallel resistance. What does mean? That's mean here we will have another new value of resistance. This value will be, we can say RT2 or on Rn, Rnu2, something like that. Here are total 2 parallel RT1 with R4. What does mean? RT1 dot R4 divided on RT1 plus R4. RT2 equal when V1 equal 15 volt. The author wrote this value to us, V1 equal 15 volt. Now we can calculate by using Ohm law the total current, because the voltage equal IR, that's mean the current equal voltage divided resistance. Here, the total voltage divided on the total resistance number 2, or the last value of all of these resistance will be 15 divided on 3.36 ohm equal like that. This amount will be important to us to can calculate the other values of current. For example, here, I4, we will come back to the main circuit, the first one. I1 equal, here R total 1 divided on R4 plus RT1 dot I total, because that this value will be important. Let's see R4 and RT1. RT1 and R4. I4 here, because that some relation between RT1 and R4, because that we use these two values. R4 equal RT1 divided on R4 plus RT1 dot IT. I4 will equal 2.5 ampere. This is the last shape, the last figure to the circuit. RT2 will equal like that. All these setups, we used it to can calculate the IT, the total current, by using the voltage current, and we calculated the total resistance. Now, RT1 and R1, RT, we can say this circuit are this resistance here are series with R1. RT1 parallel with R4 and that's mean RT1, R1 are parallel with R4, like that. We can say these resistance are RT1 and this R1, or we can say RT1 equal all of these. Their last result is parallel with R4. Yes, I1 equal IT R4 divided on R1 plus I4 will equal 1.96 approximately ampere. Now let's work on I2 and I3. I2 equal I1, not I total. We must be careful about that. Dot R3 on R3 plus I2. Let's come back to the main circuit, to the first circuit. You can take a look. The relation between I2 and I1 and resistance 3. Here, I2 here. The relation between R3 and R2, and by using the I1, that's mean I2 equal, I can remember, I1 dot R2 divided on R2 plus R3. Something like that. Let me take a look. R4, sorry, R4, R3, not R4, R3. I think I say it right thing. Yes, R3. I2 equal I1 dot R3 divided on R3 plus R2. Let us take a look again. That's right. The approximately I2 equal 0.65 ampere. I3 equal R2 divided on R2 plus R3 dot R1. Let's take a look again about R3 and relation between I1, R2, R3. R3 is here. Will be I1 dot R2 divided on R2 plus R3. That's right. Equal 1.1.3 ampere. R3. Now by using Ohm's law we can calculate V1, V2, V3 because we have I1, I2, I3. V1 equal 9.8 volts, V2 equal 5.2, I3 equal 5.2, V4 equal 15 volt. And by using all of these results, we can calculate the power because the power equation is VI. Now let's go to the second question. This, we have the same situation. We have many of resistance with different amounts. We can say we have a dependent voltage source equal 12 volts, and R1, R2, R3, R4, R5, R6. The author wanted from us find the current passing through on every resistance and find the voltage on R2. The voltage on R2 here, the V at R2, and draw circuit diagrams for every new pass, R5 and R3. Let's do the same trick to can simplify the circuit. R5 and R3 are parallel, and let's select the nodes. The nodes will be simply A, B, C, D, something like that. And we can say one of them will be the reference point. Let's select the nodes. We selected it actually, R6 and R4, R6 here, and R4. Where is R4? Here. This curve, R6 and R4 are parallel connected with the source. By this trick, we can draw the circuit, electric circuit again like that. Will be R6, will be like that. And R4 will be like that. Between of them, we can draw R1. And the trick will be here. R5 parallel with R3, because that we can select it like that, like this shape. R3 will be down and R4, 5 will be up, will be like that. We selected the nodes A, B, C, D. Now Rn1 equal R5, R3 divided on R5 plus R3. This Rnu1. This is the relation between these two resistance, R5, R3, equal 1.2 ohm. Now let's go to calculate these two series resistance. You can calculate Rn2, Rnu2 will be 5.2 ohm. I put it this sign here between these different amounts of resistance, because these resistance are series resistance. Rn2 here. Here now we have 4 resistance instead of 6. R4 and Rn2 are parallel, because that the relation will be the last value will be 3.15 ohm. R1 and Rnu3 will be series, because that's, yes, 3.15. R1 is series with R4, Rn2, series with this resistance will be Rn3 like that. Now we have 2 resistance instead of 6. All of these setups to can calculate the I total, to can benefit from it, to can calculate the other different amount of currents in the circuit. R6 is parallel with Rn3, R4 equal this equation. These two, put dots between these two different values and divided on, collect all of them. Equal 3.223 ohm. Now the total resistance is 3.23 ohm. We can calculate the total current will be 3.71 ampere. Now let's calculate I1, I2, V1, and V2. I1 equal I total. Let's come back to the first circuit. I1, the relation between I1 and I1 with resistance 1 and with R number 6. Let's take a look again. R4, the relation between R4 and Rnu2. Let me take a look again. R4 and Rn2 will be I1, I total, I1 equal I total dot R6 divided on R6 plus Rn3 to be like that 1.31 ohm, and I2 equal I1 not I total, I1 and R4 divided on R4 dot Rn2. Let's take a look again. The relation between I2, I1, R4, Rn2. I2 equal I1, R2 divided on R2 plus Rn1. The relation is like that. R4, let me take a look again. Sorry, I2 equal I1 dot R4 divided on R4 dot Rn2, because these two series resistance, these two resistance are series resistance, because that the collection, when we calculate all of these, we will find Rn2. That's mean I2 equal I1 dot R4 divided on R4 dot Rn2. That's right, 100%. I2 equal dot 8 ampere. We can calculate V2 from Ohm law. V2 equal 3.2 volt. Thank you so much. Have a good day. And thank you for your patience, your listening.